In this video, let's take a look at applications of rational functions. So there's two main types of problems we look at when we apply rational functions to real-world problems. There are work rate problems. That's when you have two people that are working together to complete a task, and you want to know how long it will take for them to work together. The other one is when you have something like this example here. At an ice cream shop, they're running a weekly special. And if you buy one cone for $5 and then additional cones are only $2.50 a piece, as you buy more and more cones, more and more lucky friends get ice cream. What's the average cost per cone? So something like that helps us to represent rational functions in the real world. So let's look at a couple of examples down here below. The first one is a work rate problem. Sarah can clean the garage in 3 hours, but it takes Angie 4 hours to do the same job. How long would it take them to clean the garage if they work together? So you would say that Sarah can clean one garage in 3 hours. So her fraction or her ratio would be 1/3. Angie is going to clean the garage, so still one garage in 4 hours. So you put 1/4 for Angie. And then they're going to clean one garage together, and you're trying to figure out how long it will take, so that's your variable. That's where you put the x. And now you can see it's a simple rational equation that we need to solve. So you can do a couple of different things. Something good to do is just get a common denominator. So 3 and 4 both divide evenly into 12. So I could turn 3 into 12 by multiplying by 4. So I need to multiply the numerator and the denominator by 4, so I get 4/12. And then I need to multiply the 4 by 3 to get 12. So I also need to multiply the numerator by 3. So I just get a common denominator of 12, and I see that I have 4/12 plus 3/12, which gives me 7/12. And then that's still equal to the 1/x, because we're still solving for how long it would take them to work together. Now at this point, you've put those fractions together, so you just have a cross-multiplying kind of problem. You can say 7 times x, so 7x equals 12 times 1, which is just 12. And then you can divide by 7, and then we can get a decimal for that amount. So let's use our calculator and say 12 divided by 7 is 1.7. So that would be 1 hour. And then what you can do is take the 0.7, that decimal portion, and multiply it by 60 minutes. And that tells you how many minutes it takes. So it takes them 1 hour and 42 minutes working together. All right, so let's look at another one. Ethan takes 15 minutes and Jake takes 60 minutes for the newspaper distribution in Mooresville. How long will it take for both of them working together to distribute the newspaper? So we would say Ethan takes one newspaper route in 15 minutes. Jake does one newspaper route in 60 minutes. And they're going to do one route together, and we put the x to figure out how long they would take working together. So again, we can get a common denominator. So 60 would be a good least common denominator because our second fraction already has 60 as the denominator. And then we can multiply 15 by 4 to turn it into 60. So also multiply the numerator by 4. And then add those together now that you have a common denominator. So you have 5/60 is equal to 1/x. Then you can just cross multiply because you have one fraction equal to another. So you get 5 times x, that's just 5x, and then 60 times 1 is just 60. And then solve for x, so divide by 5, and we just get 12. So they would take 12 minutes working together. All right, so those are two good examples of just a simple work rate problem. Now let's look at the other type of rational application we might see. So this one says, similar to the ice cream example above, how might the same process apply to movie tickets? So where the first is $12 and each additional ticket is $9, does this graph also have an asymptote, and what does it represent? All right, so to set up our function, you just want to say y equals. And then if the first ticket is $12, that's kind of a flat rate. So that's like your y-intercept in a way. And then your each additional is kind of like the slope. So this numerator kind of looks like slope-intercept form. So you have one ticket costs $12. Every other ticket costs $9. But then you want to divide by the total number of tickets. So that's just x. And then you can type that into Desmos and check out where your asymptote would be. And we'll talk about that some more. So let's type in 9x plus 12 divided by x. All right, so we can see that the horizontal asymptote looks like it's at y equals 9. And the reason it's going to always be that number is because as you buy more and more tickets, the price really still approaches that 9. The 12 gets divided up as many times as you have tickets. So if you look at the table of values for your function, you can hit enter a bunch of times and see what happens. So like as I buy more and more tickets, let's say I buy just tons of tickets, I got all sorts of friends and we're all going to the movies and I invited 67 friends. Notice it's just getting closer and closer to 9 because the 12 gets divided by all those friends that you're inviting. So y equals 9 is the horizontal asymptote. And in other words, the price of each ticket is approaching $9. So the price, let's say per ticket, is approaching, like getting closer and closer to just $9. Okay, so let's get another one of those. They said, suppose the average cost per person to attend a school's sports banquet is approximated by A of x equals 7x plus 250 over x, where x is the number of people who attend. How many people must attend to bring the cost to $32 per person? So if you want the cost to be $32 per person, you got to set that over here as the cost per person. That's sort of like your final amount. And then say 7x plus 250 divided by x equals 32. And then we can solve it. So in order to solve this equation, we want to get x out of the denominator. So let's multiply both sides by x. And then we get 32x equals 7x plus 250. Let's subtract 7x. So we get 25x equals 250. And then we just need to divide both sides by 25 to finish solving for x. So we get x equals 10. So we would have to invite at least 10 people to help bring the cost down to $32 per person. So all we did was take the 32 and put that into our, where like our y equals would be. Okay, so that's it for some examples of application of rational functions.